In this video, we will get to learn about properties of definite integrals and their application to solve various integrals. Mr. Mayank Maheshwari from Puran Chandra Vidya Niketan, Kanpur will tell us more about this topic.
Let us take some questions based upon the properties of definite integral that we discussed on the last turn. Let us integrate function 1 to 4 modulus x minus 1 plus modulus x minus 2 plus modulus x minus 3. We know that modulus of x minus 1 is equal to x minus 1 for x being greater than or equal to 1 and is equal to minus of x minus 1, that is 1 minus x when x is less than 1. Similarly for the other functions. So we break the limit. Accordingly, we know that x minus 1 is always positive for x being greater than 1 and more. So from 1 to 4, the first function is written like this. However, modulus of x minus 2 is negative till 2 and from 2 to 4 it is positive. So we break the limit as 1 to 2, 2 minus x dx plus 2 to 4, x minus 2 dx. Similarly, modulus of x minus 3 is negative till x being less than 3 and after 3 it is positive. So let us break the limit 1 to 3 and we write it as 3 minus x dx plus this is 3 to 4 modulus of x minus 3 dx. And now the integration of these functions are very simple and we can apply their limit. So we get x square upon 2 minus x within the limit 1 to 4, 2x minus x square upon 2 within the limit 1 to 2, x square upon 2 minus 2x within the limit 2 to 4, 3x minus x square upon 2 within the limit 1 to 3, and finally x square upon 2 minus 3x within the limit 3 to 4. Now we can apply the limit one after the other and solve this integral. So this is one application of the property of definite integral in which we break the limit.
Can you guess the value of mod x minus 1 for x greater than or equal to 1 and x less than 1? The solution is, there can be two values for a mod function depending upon the intervals. That is, mod of x minus 1 is equal to x minus 1 for x greater than or equal to 1 and minus whole of x minus 1 for x less than 1.
Now let us come to another example. Let us come to the second example. Integral 0 to pi by 2 log tan theta d theta. If we apply the property 0 to a fx dx is equal to 0 to a f of a minus x dx, then we get I is equal to 0 to pi by 2 log tan pi by 2 minus theta d theta. Now we know that tan 90 minus theta is cot theta. So it becomes log cot theta d theta within the limit 0 to pi by 2. Now let us add integral 1 and integral 2. They both are under limits 0 to pi by 2. So we get 2i is equal to 0 to pi by 2 log tan theta plus log cot theta d theta. Now we know that log m plus log n is equal to log of mn. So we get 2i is equal to 0 to pi by 2 log tan theta cot theta d theta. We know that tan and cot are reciprocal to each other. So this becomes 0 to pi by 2 log 1 d theta. Also we know that log 1 is 0. So this becomes 0 to pi by 2 0 d theta, which is 0, and hence the integral I comes out to be 0. Take another example. Question number 3. Pi by 6 to pi by 3 dx upon 1 plus under root of cos x integral. Now, if we use the property a to b fx dx is equal to a to b f of a plus b minus x dx, then our integral I, which is equal to pi by 6 to pi by 3 dx, and on changing in cos and sine becomes 1 plus root cos x upon root sin x, which is equal to pi by 6 to pi by 3 root sin x dx upon root sin x plus root cos x dx. This integral, on applying the property, when we apply the property a to b fx dx is equal to a to b f of a plus b minus x dx, becomes I is equal to pi by 6 to pi by 3 under root of sine pi by 2 minus x dx upon under root of sine pi by 2 minus x dx plus cos pi by 2 minus x. Now sine 90 minus theta is cos theta, cos 90 minus theta is sine theta. So our I becomes pi by 6 to pi by 3 root cos x dx plus root cos x, in the denominator root cos x plus root sin x. This is our I. This is, say, equation number 2. If we add equation 1 and equation 2, we see that both the integrals are in the same limit pi by 6 to pi by 3 and they have the same denominator. So 2i becomes pi by 6 to pi by 3 root cos x plus root sin x dx upon root cos x plus root sin x. This entire thing cancels out. So this becomes simply integral of 1 dx, which is x. When we apply the limit, it comes out to be pi by 3 minus pi by 6. On taking LCM, it comes out to be 2 pi minus pi whole upon 6, which is pi upon 6. And hence, I becomes pi upon 12. This is one of the application of the property a to b fx dx is equal to a to b f of a plus b minus x dx. Now, let us consider another example. Take question number 4. Minus pi by 2 to pi by 2 sine to the power 5x dx. Now, we know that minus a to a fx dx is equal to 2 times 0 to a fx dx if function fx is an even function. However, this becomes 0 if it is an odd function. As far as in this question, we have fx as sine to the power 5x. So f of minus x is equal to sine to the power 5 of minus x, which is minus sine to the power 5x and hence minus fx. So clearly this is an odd function and hence the integral value becomes 0 using the above property. Now let us take another example. I is equal to 0 to pi by 2 sine to the power nx dx upon sine to the power nx plus cos to the power nx. This n could be any integer, any positive integer in fact, and it can be any fraction as well. So the question could be root sin x upon root sin x plus root cos x dx, or sine to the power 3 by 2x sine to the power 3 by 2x plus cos to the power 3 by 2x, and so on. So there are many questions of this variety, and we will see Interestingly, they all have the same answer. Now, let us apply the limit. Let us apply the property 0 to a fx dx is equal to 0 to a f of a minus x dx over here. So this gives us sine to the power n pi by 2 minus x dx, and same over here. Now we all know that sine 90 minus theta is cos theta, whereas cos 90 minus theta is sine theta. So this becomes 0 to pi by 2 cos to the power nx plus sine to the power nx dx. Once again, if we add these two integrals, we get 2I is equal to 1, and the integral of 1 is x, which on applying the limits gives us pi by 2. So I comes out to be pi by 4. So in all such cases, the answer will be pi by 4. The question could be somewhat like this as well. Here also we'll be getting the same answer.
For more such videos, log on to CBSE section of jagranjosh.com.